I'm John Dewan, and I'm going to be explaining the physics of swimming. Naturally, swimming has been around for thousands of years. Man had to get from point A to point B somehow. What you're seeing right now is the cave paintings of Gilf Kebir, depicting prehistoric man swimming. However, swimming was not widely practiced until the early 19th century, when the National Swimming Society of Great Britain began to hold competitions. Most early swimmers used the breaststroke or a form of it. Freestyle or the front crawl was not invented, or at least discovered, until the late 1880s, when an Englishman by the name of Frederick Cavil traveled to the South Seas where he witnessed the natives forming a crawl with a flutter kick. Swimming has been featured in the Olympic Games since 1896. The very first Olympic events were freestyle and breaststroke. Backstroke was not added until 1904. In the 1940s, breaststrokers discovered that they could go faster by bringing both arms forward over their heads. This practice was immediately forbidden in breaststroke, but gave birth to butterfly, whose official appearance was at the 1956 Games in Melbourne. These four strokes make up the strokes used in official competition. Now this relates to me because I swim. For a swimmer, in order to beat the person next to you, you must be able to push the water and propel yourself faster than the person next to you. In order to determine this, some physics must be involved. There are many factors involved in swimming, including water resistance, drag, as well as force. However, the most fundamental concept of physics involved in swimming is most likely Newton's three laws of motion, specifically the third. Put simply, Newton's third law states that when force is applied on an object, that object will return the favor and apply an equal force to you, in the opposite direction. Therefore, when a swimmer pushes towards the wall, they will propel themselves forward through the water. As previously stated, drag also plays a role when moving through water. Much like how a cyclist must minimize the surface area they present to the wind, swimmers also have to create as little resistance to the water as they possibly can. In this case, that means making the body completely horizontal, not breathing flags to the wall, and slicing your hands through the water. It's worth noting that swimming in seawater is harder than swimming in pool water, for multiple reasons. The sea is almost always turbulent, making it much harder to move through the water. Also, seawater is much more dense than freshwater due to the salt it contains. Unlike with running or cycling through air, it is hard to build up any momentum in the water. The resistance is much greater. This is a demonstration of the first law of motion. If water were as light as air, swimmers would be able to glide through the water as much as a cyclist who stops pedaling and uses momentum to keep him or herself going. This is all speculation, however, as the water pushing against a swimmer will rapidly bring him or her to a halt. You also experience inertia when you try to change direction, since velocity is speed in a particular direction, and force will be required, even if moving at a constant speed. If you're swimming straight, it is quite hard to stop and turn around without stopping and reversing or doing a somersault. That is, of course, unless you can do this. With freestyle, the objective is to extend your hand as much as you can and bring it back as far as possible, dragging as much water back as you're able to. If you make a long, complete stroke with the proper follow-through, you're applying your pulling force for longer and each stroke will count for more. You can see this from Newton's second law of motion, which is as follows. This can be rewritten to form force times time is equal to mass times velocity. To put it another way, in order to produce the biggest possible change of momentum, you need to apply your force or pulling back on the water for as long as possible, with as long a stroke as possible and a good complete follow-through. It's also worth remembering that our human body is like a machine. Our limbs work like levers pivoted at our joints, which are basically our fulcrums, multiplying force or speed. When you're doing freestyle, it's important to reach forward and pull the arm backward as much as you possibly can. This gives you more leverage on the water, and the force you create pulling backward will give you more force to go forward. Alright, well that was it. I hope you enjoyed and learned something about swimming.